smallest stars are called red dwarfs, and they may contain as little as 10% the mass of the Sun and emit only 0.01% as much energy. Glowing at temperatures between 3000 and 4000 Kelvin. I can't even imagine that kind of heat. Red dwarfs are the most numerous champagne supernova. In a supernova, the star's core collapses and then explodes. In just a matter of seconds, the core shrinks from roughly 5,000 miles across to just 12 miles across. And the temperature spikes 100 billion degrees or more. freaking expert. But I find this stuff very cool. I really enjoy learning about the size of the universe. I mean, I still can't fathom it. I have no idea. But it makes me feel very small, but like in a good way. You know, it makes me feel like the small things that I overthink, like, don't really matter that much in the scale of the universe. Do you believe in aliens? Let me know down below, because I do. Okay, so the title of this article is Hunting for a Giant Black Hole. Astronomers found a nest of darkness. No, Gargantua dwells at the heart of stellar cluster NGC 6397. Instead, a few dozen smaller black holes seem to be swarming around in there, throwing their considerable masses around. This is written by Dennis Overby. Two astronomers recently went looking for a monster black hole. Excuse me. They sifted reams of data from the most powerful telescopes on and above Earth for any sign of an invisible object, hundreds of times the mass of the Sun. Sorry. In a distant cloud of stars known as NGC 6397, what a romantic name. Instead, they found a nest of baby monsters, as many as 5 dozen. That kind of freaks me out. Dark engines of annihilation packed into a space barely larger than our own solar system, buzzing back and forth and throwing their considerable weight around in the dense core of the star cluster. Eduardo Vidal and Gary Mamon of the Paris Institute of Astrophysics, using data from the Hubble Space Telescope and the European Space Agency's Gaia spacecraft, reported their results on February 11th in the journal Astronomy and Astrophysics. Oh, sorry, I ran out of breath there. We found very strong evidence for an invisible mass in the dense core of the globular cluster, Mr. Vidal, a graduate student, said in a news release from the Space Telescope Science Institute. Wouldn't it be cool to be a graduate student and to find something as cool as 5 dozen black holes in the middle of a star cluster? But we were surprised to find that this extra mass is not point-like. The surprise result has given astronomers a unique and detailed look at the dynamics prevailing inside one of the most crowded places in the nearby cosmos. Their work suggests that such clusters are a likely source of the gravitational waves that have been detected by antennas like LIGO and Virgo in recent years, and that originate from colliding black holes. But the discovery raises questions about the presumed and confusing process by which small black holes, only a few times as massive as the Sun, can merge and smaller galaxies, or galaxy fragments like NGC 6397. But so far, these intermediate black holes are missing in action. The cluster NGC 6397 is one of about 150 spherical clouds of ancient stars that orbit the Milky Way and perhaps predate its formation. It is 13 billion years old and contains about 250,000 stars, all of them old, small, and dim. The brighter, heavier stars in the cluster long ago burned through their lives and met their fate as black holes or other products of stellar decay. So the cluster is a likely candidate to harbor an intermediate mass black hole. Indeed, earlier studies had suggested that a black hole of about 600 solar masses anchored the center of NGC 6397. To investigate that idea, Dr. Mahamon and his student turned to high-resolution observations of the motions of individual stars in the cluster, obtained by the Hubble Space Telescope and Gaia. The faster stars were moving, the greater the gravitational force, and hence more mass must be present to hold them in the cluster. In all, 1,905 stars from the Gaia catalog and 7,209 stars from Hubble were appraised. There was no sign of a gargantuan black hole. Our analysis indicated that the orbits of the stars are close to random throughout the globular cluster, rather than systematically circular or very elongated, Mr. Mammon said in an email. The motions of those stars offered evidence of a dark mass equal to 1,800 suns spread across a region, a cloud within the cloud, about 1/3 of a light year wide. Sharing that space are some 40,000 ordinary, luminous, but very lightweight stars. According to models of stellar evolution, Dr. Mammon said about 2/3 of this dark stuff would be black holes, with the average mass of 20 suns. The rest of the dark material would be remnants of dead stars, such as white dwarfs or neutron stars. What will happen next is not clear, the astronomer said. Random mergers between the black holes could cause them to lose mass in the form of gravitational waves. Such mergers could also